Hi, my name is Mr. Chon. You are welcome to my study room. In today's study, we are going to learn a few features of the graph of a quadratic function or a quadratic equation, which is also called the parabola. So, I've titled today's lesson, What You Need to Know About a Parabola. And I'm going to use the Desmos graphing software to help me explain this. Let's now go into the day study. The first feature or the first thing I would like us to know about is the vertex of the graph. The vertex of a parabola is the peak of the parabola. For a parabola opening downwards like the one we have here, the vertex is the highest point, and for a parabola opening upwards the other way around, the vertex is the lowest point. From the parabola here, this is the vertex. We coordinate 1 and 4. For that matter, we will say that the vertex of this parabola is 1, 4. The second feature I would like to talk about is the axis of symmetry. This is a vertical line that divides the parabola into two equal halves, and this line must always pass through the vertex. So from this graph, this is the axis of symmetry. It passes through the vertex, and just like I said earlier, the axis of symmetry divides the parabola into two equal halves. So the right half here will completely overlap the left half when we fold it along this line of symmetry, meaning that it will fold exactly onto it when we fold it along this line. Our axis passes through 1. So for a vertical line that passes through x equal to 1, the equation of the line of symmetry is simply x equal to 1. Because for every point along the axis of symmetry, the value of x is 1, or the x coordinate is always 1. Therefore, the equation of the axis of symmetry is x equals to 1. And that is only for this graph, because the axis of symmetry passes through 1 on the x-axis. That's why we are saying the axis of symmetry for this graph is x equal to 1. Let's now take another feature, the y-intercept. This is the point where the parabola intersects the y-axis. In this case, it is 3. There it shows on the graph. So the y-intercept from this graph is 3. Or those who would like to write it as a point will have 0, 3 as the y-intercept, because the graph intersect the y-axis at 3. This is 2, 3, and 4. Let's take the next vocabulary, or the next thing we need to know about the parabola. Number 4, the x-intercept. These are the points where the parabola intersects the x-axis, and the x-intercept can be 1, 2, or not intercept at all. In this case, the x-intercepts are 2, and let me just show that on the graph quickly. Here and here, always I want to show the point. -1 and 3. We can simply write them as -1 and 3, or again, if you want to write them as points, then we write them as -1, 0 or 3, 0, because the y coordinate on the x-axis are both 0. So those are the x-intercept. Then let's move on to the next one, the domain of a parabola. These are the set of x values that make a function defined. The parabola is defined for all x values. What I mean by defined for all x values is that you can see that when you draw a line from here, it will touch the graph, and then as you go along it will be touching the graph this way, and as it goes down the graph will also keep expanding towards the right. So any value you reach on the x-axis to touch the graph, when you come to the left too, it will still touch the graph. And it's not only for the integers, but any number in between, like any point in between, will still touch the graph along all places. So because of that, the domain for any quadratic function is all real values. X belongs to all real numbers. Yeah, so the domain for any quadratic function or quadratic graph is all real number, because any number along the x-axis will touch the graph. We write it this way, or from negative infinity to infinity. Any of them is acceptable. Then let's get to the next one, which is the range. These are a set of y values for which a function is defined. So the domain is a set of x values for which a function is defined, and the range is a set of y values for which a function is defined. Here the parabola goes as high as the 4 here. It cannot go up again, because at its ascent up to this place it goes down. However, the parabola can go as low as you want. You can see as you stretch, you can see that it keeps going, and it can go as low as it likes. It will never end anywhere. Therefore the range of y must be 4 and anything below. Because of that, we will say that the range of this function is y less or equal to 4. As I said earlier, it is only found along the y-axis, and then the domain is found along the x-axis. So any value from 4 and below will lie within the graph. That is just what the range is for. From here, any horizontal line you draw, as low as you want it to go, it will cut the graph. But you can see that anything above 4 will not cut the graph. That is just what I'm trying to explain here. And if it is the other way around, let's say the graph opens upwards, then that one, it will be from the y coordinate at the vertex upwards. So it will be y greater or equal to the y coordinate at the vertex. But this is less or equal to, because the graph opens downwards, and any y value within the range will be less than the 4 or equal to the 4, from 4 or less. Let's take the next one. The next thing we are looking at is the minimum or maximum value. The minimum or maximum value of a graph or a function is always a y value, because to measure minimum or maximum will be along the y-axis. We go either up or down. Since the parabola can go as low as it likes, there is no minimum value. Remember, we said it here. So since this parabola can go as low as it likes, there is no minimum value. However, it can only go as high as 4. When it reaches 4, you can see that it doesn't go above 4, but it can go as low as any value it likes, and I've demonstrated that earlier. Therefore, we say the maximum value is 4, or maybe y equals 4, but the maximum value is 4. And I explain, you know why. That means that for graph of this nature, you can only have maximum value when the graph opens downwards, and you have a minimum value when the graph opens upwards this way. Then here becomes the minimum value. So the most important thing you need to keep in mind is that the minimum or maximum value can be calculated only along the y-axis, and it is always the y coordinate of the vertex, because beyond that value it cannot go either up or down. So that is the maximum value for this graph. 4 is the maximum value. These are few vocabularies I would like you to know about a parabola. Just to recap quickly, we spoke about the vertex, where we said it is the peak or apex of the parabola, and from this one we said that the vertex is here and we showed the coordinate here, and then from there we went to talk about the axis of symmetry, which is a vertical line that passes to the vertex of the parabola, and we said that the axis of symmetry is 1 for this particular parabola because any point along this vertical line, the x value there will always be 1. That's why we say it is the equation of the axis of symmetry. Then we went ahead to talk about the y-intercept. We said the y-intercept is where the graph intersects the y-axis, and in this particular case the graph intersects the y-axis at 3. So the y-intercept is 3, or if you want to write it as a point, then we write 0, 3, because the x value along the y-axis is 0. So if you want to write them as coordinate, then 0, 3. Just like the y-intercept, the x-intercept is where the graph intersects the x-axis, and in this case we have -1 and 3. And then again, if you want to write them as coordinate, then write -1, 0 and 3, 0, because the y value along the x-axis is 0. Then we spoke about the domain, where we said the domain are the x values that make the function define. And for any quadratic graph or parabola, all x values define the graph, because anywhere we move along the x-axis, the graph is defined through there, because any line drawn through any of these lines, whether through the integers or different values between them, it will touch the graph. So we concluded that all real numbers for the domain of a parabola. Then we went ahead to talk about the range. We said the range of a parabola is the set of y values that make the graph define. And then that one we demonstrated that when we draw any horizontal line along this y-axis, it will touch the graph only from 4 downwards. Any horizontal line after 4 and upwards, it will not touch the graph again. So this is not part of the range. For that matter, we concluded that the range is any value from 4 downwards, and that is y less or equal to 4. Then we spoke about the maximum and minimum value, where we said that depending on the nature of the parabola, the minimum or maximum value is the lowest or highest point on the graph, respectively. For this particular parabola, which opens downwards, the highest point of this graph is 4 along the y-axis. For that matter, the maximum value is 4. But if were to be a graph that opens upwards, then the lowest value is going to be at the vertex, and is the same as the y-coordinate of the vertex of the graph. I hope to have more lessons on parabolas, but this is where I end today's lesson. I hope it has been of help to you. If yes, then kindly consider subscribing to this channel for more videos. Till we meet again in my study room, it's a bye. Thank you.